Okay, we're going to talk about graphing solutions of equations here. This is lesson 81, and so far we've talked about the slope-intercept form, which is y equals mx plus b. Remember, the b part is the y-intercept, or in other words, where it crosses the y-axis. The number in front of the x is called the slope. Remember, slope is rise over run. And if it's a negative slope, the line's going downhill. If it's a positive slope, the line's going to go uphill. And we're going to continue here with graphing of these equations. And let's get to the first example. Okay, in example 1, it says solve by graphing. So in other words, they have two equations. And what we're going to do is we're going to graph those two equations. And we're going to see where they cross. Because the point where they cross then is going to be the solution to these two equations, as you'll see here in a little bit. So in the blue, and I'll put a little blue dot here, I'm going to graph that equation. And in the red, I'm going to graph the other equation. All right, so let's start with the blue one. All right, so let's see, it's going to cross at a positive 1. The slope, really there's a 1 in front of there, right? So the slope is 1 over 1. And it's positive. So in other words, my line is going to go uphill. So I'm going to start at where I have the dot, and I go up 1, right 1, up 1, right 1. Or I could go down 1, left 1. And I get a line that's going uphill. So let's graph that now. I'm going to draw a line, and I'm going to draw that line out a ways because that's important, because we want to see where these two lines cross. And something like that. So this line that I just graphed then is y equals x plus 1. Right, now I'm going to do the red one. Now the red one, the y-intercept is positive 4. So 1, 2, 3, 4, it crosses the y-axis at 4. And this time the slope is negative, meaning the line's going to go downhill. Now what is the slope? Well, it's 2 over 1. So I would go up 2. Now, would I go left 1 or right 1 for the line to go downhill? Well, I'd have to move left 1. Then I could go up 2, left 1. And I can get a number of points. Or I could go down 2, right 1. Down 2, right 1, and something like this. All right, now I'm going to draw my line. And I want to try to draw that right through those points now. The name of this line was y equals a negative 2x plus 4. Now where do these two lines cross? And to answer that, they cross right there. They cross at that point, which would be, let's see, right 1, up 2. That point would be 1, 2. So the solution to this set of equations is 1, 2. Because if I put 1 in for x and I put 2 in for y into either of these equations, it's going to make both those true. So for example, let's do that. So in the first, in the blue equation, let's do that. So let's see, y is 2, right? Equals x is 1 plus 1. Well, is 2 equal to 2? It is. See, it makes that equation true. Now in the right one, or in the red one I should say, let's stick 2 in for y equals a negative 2 times whatever x is, which is 1, plus 4. Let's see if it makes this one true. Is 2 equal, what's a negative 2 plus 4? 2 is equal to 2. So as you can see, this right here made both those equations true. That's the solution to those two equations. And we found the solution by graphing them, which is what we're doing in this section. Okay, let's do another one. Again, I'm going to do the first one in blue and the second one in red. Now I'm going to, in the blue one here, let's see y equals 2. That's easy, right? There's not an x involved, so it's just simply going to cross the y-axis at 2. So let's see, y-axis at 2. And it's going to be completely horizontal. So it's going to look something like that, right? So that one was easy. Okay, now on the red one, I'm going to adjust this a little bit. Really, this means plus 0, right? So the y-intercept is 0, and there's a 1 in front of the x. So that's the slope. Okay, so it's going to cross at 0. It's a positive slope, which means the line's going to go uphill, and it's 1, 1. So up 1, right 1, up 1, right 1. And you can already see where the lines are going to cross. Or go down 1, left 1. Now I'm going to graph that. Try to get my line right through those points because being precise is important. And you can see then where these two lines are going to cross. You can see that these two lines are going to cross right there. And that point would be, let's see, right to, up to. That point, or in other words, our solution is 2, 2. And again, if I stuck 2 in for x and 2 in for y into either of these equations, it's going to make it true. For example, in the top one, if I put 2 in for y is 2 equal to 2. It is. It makes it true. Now, you might be asking, will two lines always cross at a definite point like this? So in other words, will they ever cross at in between, something like that? And the answer is yes. The equations that you have on this lesson, they're always going to cross at a definite point. Okay, let's do one more. Top one I'm going to do in blue. Bottom one I'm going to do in red. I'm going to go through this a little faster. All right, so the top one, it's going to cross at a -2. It's going to be a positive slope, right? It's going to go uphill. So let's see, the slope is 1 over 1, right? So up 1, right 1, up 1, right 1. Or I could go down 1, left 1, and I have my positive line, or my line going uphill. And my line would look like this. Draw your lines out so you can see where the lines might cross. They might not cross right away, and if you draw short little lines, it's going to take you won't be able to see where they do cross. All right, so I'm just trying to get those going right through that point as best as I can. All right, now in the red one, it's going to cross the y-axis at 5. So 1, 2, 3, 4, 5. Negative slope, the line's going to go downhill, isn't it? Okay, so go downhill. Oops. Change that around. So my line's going to go downhill. And my slope is a negative. My slope is 2 over 1 now, right? So that's a 2 over 1. So let's see, positive 5. I need to put my 5 down there again. 1, 2, 3, 4, 5. So right there. Okay? And here, I see I made a mistake here. I want this first line to be in blue, don't I? So just pretend it's blue. I'll overlap it with blue. Okay, go up 2. Then which way for a downhill slope? Left 1. Up 2, left 1. Or I could go down 2, right 1. And that's going to be my line in red. Something like this. Okay. Now, let's see here. So what I have, this one's a little different. It could be, and for the problems that I gave you here, they should cross at a definite point. Right here they don't, but that could be because of the way I'm graphing it. I might be just a little bit off. Let's see, 1, 2, 3, 4, 5. Looks like if I made this a little bit more precise, made my dots a little smaller, they should cross right there, okay? And I'm just checking to see if there's anything else that needs to be a little bit more detailed. So now, according to what I'm saying, the solution would be right 2 and then not going up or down in. Let's test this to see if that's correct. So let's take the y equals x minus 2. Let's put 0 in for y, and let's put 2 in for x to see if that is the solution. Let's see, is 0 equal to 0? It is. So that makes that true. Now what you could do with the other one is do the same thing. Stick 2 in for x and 0 in for y and see if it makes that true. And it looks like it would. Okay? Let's just test it real quick. Let's see, so 0 equals a -2 times whatever x is, which is 2 plus 5. 0 is equal to a negative 4 plus 5, 0 equals a negative 1. Okay, now here it doesn't, it does not. Okay, so this is an example that I picked out. So really 2, 0 is not the solution. So it's actually probably not going to cross at a definite point here. So probably a bad example that I picked out, at least for introducing this, because these points actually are not going to cross right at a definite point. And you're going to get some fractions or some decimals involved. And we'll hit on that, what you do in that type of situation. For now, though, you're going to have, they're going to cross at a definite point, like example 2 does, and the example 1 does.